Woohoo! Welcome back. Today we're going to be working with a difference quotient, and I've asked my friend Blue Dinosaur to help us. This is a problem I've taken from the homework. So when you look at your homework, your problem may be slightly different, but the method will be the same. In order to calculate a difference quotient, and again, I'll remind you that difference quotient means subtracty dividey thing, right? So we're going to subtract something and we're going to divide something. But the first step is actually to work out what f of x plus h is. This piece right here, if I can find my, let's see, let's go with blue. I want to do blue. There we go. This piece right here is going to be the first part of the difference quotient. So in this particular homework problem, the book is going to ask you to work this out first. So in other words, they're chunking up the problem into smaller pieces, which is a great idea. So this comes down entirely to using function notation. So if I have f of x plus h, that means when I look at f of x, wherever I see the x in the original, and in fact, let me go ahead and get started, not by putting an equal sign there yet. Let me write out f of x is equal to 6x squared minus x plus 8. And I'm going to use a little yellow. So in other words, whatever's inside here, multiply by 6, square it, subtract it, and then add 8. So in this particular problem, instead of x, we want x plus h. Now, I know this can be a little bit confusing because your brain is really smart and it's going to say, wait, there's an x, I see, and you're going to have to say, yes, those both are x's, but they're not exactly the same. This is the first time when x went through alone, and this time x plus h is going through together. So we have to follow the same pattern. The 6 stays the same. Wherever we see an x up here, we get an x plus h down here. So this will be x plus h, the quantity squared. So in this case, we have to make sure x plus h gets squared all together. Then we're going to subtract, and up there we subtracted x, so we're going to subtract x plus h. So wherever there's an x, there's going to be an x plus h. And it's really helpful if while you're writing this, you keep x plus h in parentheses, because a lot of times you're going to have to do that. For example, to make sure the whole thing gets squared, to make sure the whole thing gets subtracted, to make sure you multiply 6 times the whole thing. And then the last part is just a plus 8. There's no x here, so there's no x plus h down here. Okay. Now that we've got that written down, what remains is to multiply this out. And I'm going to ask our dinosaur friend to move over a little bit. Excuse me. He's right here, still there for support. I'm going to make a note right here, take some of this work over here and say x plus h, the quantity squared, is just x plus h times x plus h. In this class, we're going to work with perfect squares enough that it might be worth it to you to memorize the formula, or you can always use FOIL or whatever other method you use for multiplying a binomial, that's 2 terms times another binomial, 2 terms. So if I'm going to use, if you don't know the formula, I'll just use FOIL, first, outer, inner, last. First is x times x. Outer is x times h. Inner is h times x. Last is h times h. And there are pluses everywhere in between because it's all positive. So then what we get is x squared plus xh plus xh plus h squared. And then I notice that the 2 terms in the middle are matching, and we get x squared plus 2xh plus h squared. Notice that this is the formula for a perfect square. It's the first term, the x squared, the last term, the h squared, and then a mix in the middle, 2xh. That's the O and the I normally in the FOIL. So this is the formula that you may want to memorize while we're going through these sections. If you can resurrect them, there's probably a point in your past when someone had asked you to memorize it, so it might just be hiding in a back closet or your attic in your brain. And if not, you can always multiply out. That's always an option. So I'm going to take advantage of that. And in fact, I think I'm going to have to, so let me, before I even do that, I think I was a little bit optimistic about how much space I would need. So I'm going to rewrite the second part, the B part, and then go ahead and give myself some extra room. Whenever something is really complicated or making you feel nervous or just, just not going necessarily so well, or, whatever, if you feel like it, giving yourself more room is always a great step. So give myself a little bit more room so I don't have to get too small with this. And then let's go ahead and continue. So x plus h, the quantity squared, is this guy right there. So it's 6 times, I'm going to use a big bracket to remind myself I move this in. You don't have to. Plus h squared minus x plus h plus 8. The way that I look at things, parentheses sometimes are just too squiggly for me, and brackets help my brain to separate things out. It's always an option. You don't have to do it. Okay, now I'm going to go ahead and multiply through. The 6 is going to distribute throughout. So I get 6x squared plus 12xh. Notice 6 times 2x is going to give me that 12xh plus 6h squared. Make sure the 6 is in every term. Every term here gets a 6. Then I'm going to distribute this minus, which you can think of as an opposite or as a -1. So minus x minus h, and then plus h. And then it turns out that's it. We can take a look at this, but basically nothing here is going to simplify, unfortunately. There are no like terms. So this is the answer to part A. Woohoo! We did it, part A. Nice. Okay, now let's do the second part. So f of x plus h, f of the quantity x plus h, is the first part of the difference means subtraction, quotient division. So this is the subtractee dividey guy. So this is one of those problems where you may want to actually turn your paper sideways to give yourself more distance across because it gets a little squashy. But basically here, and I'm going to use brackets for everyone because again, there's a lot going on. I'm going to copy down what I got in part A. You can see why this takes so much space. So this part is this right here, which is from part A. That's this right there. Okay. So I've got that, and then I'm supposed to subtract f of x. I'm going to put in another set of brackets, and again, you can use parentheses. I just find brackets to be easier to parse with my brain. So I'm going to put in f of x, which is up here, we're given it. F of x is 6x squared minus x plus 8. So that's going to be, let's see. This is just up here. So these two, okay? And then it's all over h. There's just an h, and don't deal with the h yet. The h plays a part, but we don't use it right now. Thank you for being there, Blue Dinosaur. I want to make sure that I don't smash you. There we go. Okay, next step. And again, as always, you will probably use fewer steps than I use. I just want to make sure I leave lots of breadcrumbs. And I explain what I'm doing. So the first step is, because there's nothing in front, these brackets can get dropped. I'm not multiplying through, I don't have an opposite of, so I can just write this without the parentheses or the brackets. Now over here, I need to remember to multiply through either by the opposite of or a -1, depending on how you view it. So I'm going to change the sign so it becomes minus 6x squared plus x minus 8. And again, there's an over h just hanging out. So I'm going to now take this and I'm going to combine and look for like terms. So notice I've got a 6x squared and a minus 6x squared. And then I've got a plus x and a minus x. And instead of crossing them out, which would make the notes very hard to see, I'm just adding little dots. I could always use colors too, but I feel like I've used a lot of colors here and I don't want to depend on the colors. And then the 8, and then the minus 8. Now, the great thing about difference quotients is the ones that we're going to be working with in this class will always cancel like this. So all of the purely x terms will always cancel. So that's how you know you've done it well, is then when you look at what isn't canceled. So these two cancel. So I've got a 12xh and then a plus 6h squared. That canceled, and then a minus h, and that's everything. You will know you've done it correctly if everything you have left has an h in it. So it's going to work out beautifully. Now, if you do go on to take a full semester of calculus, you're going to find that these do get more complicated and you have to do even more convoluted things to sort them out. But we're going to leave that to another class. In this class, these are the ones that we really want to look at, because it turns out that x squared, in general, functions that have x squared are really good for modeling economics. So parabolas are really excellent. So I've got 12xh plus 6h squared minus h all over h. Now, a lot of people are tempted to cancel the h's and be done. But remember that when you have 3 terms in the numerator, there's pluses and minuses in between. You can't just cancel once, you have to cancel everybody. And the easiest way to do this is to factor. So since I want to cancel an h down here, I'm going to factor an h out of the numerator. Can I do that? The answer is yeah. There's an h here, there's a couple h's here, another h here. So I'm going to just pull one of them out. So if I factor out an h, the first term, what's left is 12x. Factor an h out of 6h squared, I get plus 6h. And factor an h out of minus h, and I get -1. And then, oh, I don't have my red pen of destiny. Well, I have a similar pen. So I'm going to take this and I'm going to go ahead and cancel the h's. And my final answer is 12x plus 6h minus 1. Okay, woohoo! Hopefully that made sense. This particular example is one of the hardest problems in this class, turns out. And so if you're not getting it, talk to me, talk to tutors, look online, ask lots of questions, and, the tutors and I will do our best to make it make sense. But to a certain extent, it just takes a lot of practice. This one, you're not imagining things. This one can be really tricksy. So, good work. Know that you're awesome. Go outside, look at something green, get some fresh air, get a little sleep. Make sure you're drinking enough water. Make sure you got those veggies on board. You're getting enough protein, all that stuff. Take care of yourselves. Pat yourself on the head and say, you did a great job today. And I will talk to you later. Math on, guys. Math on.